Now we will move towards the next example. So in this example as well, it is asked to us whether this function is onto bijective or not, and if this function is bijective, we are supposed to find the inverse of it. So again, the one part I leave it to you, that is homework. So directly we will move towards the onto part. So I will say for any. Now just note one thing, the domain and codomain of f are different here. So f is a function from r minus minus 3 upon 5 and r minus 9 upon 5. So your f inverse will be a function from what? It will be a function from r minus 9 upon 5 to r minus minus 3 upon 5, right? This should be clear. So here I will say for any y belonging to, so what is our codomain of f? It is r minus 9 upon 5 to find x belonging to, what is our domain? R minus of minus 3 upon 5 such that f of x is equal to y. Now our ultimate aim is to find the value of x by solving this. So what is our f of x? Our f of x is nothing but 9x plus 5 upon 5x plus 3, which is equal to y. Now we need to solve it for the value of x. So I will say this implies 9x plus 5 is equal to 5xy plus 3y. This implies, as we need to find the value of x, so I will shift all the terms of x to one side. So 9x minus 5xy will be equal to 3y minus 5. Therefore, now we will take x common, so it will be 9 minus 5y will be equal to 3y minus 5, and therefore x will be equal to 3y minus 5 upon 9 minus 5y. So now we got the value of x. So the question is whether whatever value of x we have found out, whether it belongs to domain or not. If it belongs to domain, then and then only we can conclude that our function is onto. Now let us try to understand how domain is defined, or what exactly the domain set is. So domain set is nothing but the set of real lines only, but one point is removed from the set of real lines, and which point is removed? Minus 3 upon 5. So if we are able to successfully show that this x is other than minus 3 upon 5, then we are through. Because what is the issue here? The issue is whatever value of x we got, remember y is from codomain, this set, so y is a real number, so no issues with that. So whatever answer we get here, it is going to be a real number. Only the thing is that real number should not be equal to minus 3 upon 5, because if the real number x is equal to minus 3 upon 5, then this will not be there in the domain. Is that fine? So in order to show that it is present in the domain, we need to show that it is not equal to minus 3 upon 5. So what I will say here, I will say now to show this x which is equal to 3y minus 5 upon 9 minus 5y belongs to r minus of minus 3 upon 5. That is nothing but we have to show x is not equal to minus 3 upon 5, and we are going to prove it by contradiction. So I will say, on contrary, assume that x is equal to minus 3 upon 5. So actually we do have the value of x. Value of x is nothing but 3y minus 5 upon 9 minus 5y, so which will be equal to what? Minus 3 upon 5. And let us see what we get here. So therefore, after doing cross multiplication, we will have 15y minus 25 will be equal to minus 27 plus 15y. So this 15y and 15y will get cancelled out, and this implies 25 minus 25 is equal to minus 27. That is nothing but 25 is equal to 27. Is it true? Absolutely not. So I will say which is a contradiction. Therefore, our assumption is wrong. Therefore, what should be right? Therefore, x is not equal to minus 3 upon 5, and therefore x is equal to 3y minus 5 upon 9 minus 5y belongs to domain that is nothing but r minus minus of 3 upon 5. And therefore, I will say that therefore, for any y belonging to r minus, what was our codomain? R minus 9 upon 5, there exists x is equal to 3y minus 5 upon 9 minus 5y belonging to domain such that f of x is equal to y, and therefore f is onto. Remember that we have already shown f is 1 1, thus we can conclude that f is bijective, therefore f is bijective. Since f is bijective, we can say that f is invertible. Now, since f is invertible, definitely we will be able to find its inverse. So, now I will say to find f inverse. We know f of x is equal to y if and only if f inverse y is equal to x. And what is our value of x? Our value of x is nothing but 3y minus 5 upon 9 minus 5y. So, therefore, f inverse exists, right? Therefore, f inverse is a map from what? R minus. Now, what was our codomain of that function? The codomain was R minus 9 upon 5. Now, that is going to be our domain. So, R minus 9 upon 5 to R minus minus 3 upon 5, defined by f inverse of x is equal to 3y minus 5 upon 9 minus 5y, and that is exactly what we wanted to do. So, here in this lecture we have seen the definition of invertible function, and we have seen some examples on that, and there is one interesting note as well. So, if we need to find the inverse of a composition function, that is f composition g, suppose let us say f is a function from a to b, and let us say g is a function from b to a, then we know that the f composition g will be a function from b to b that will exist, and the inverse of that f composition g is given by g inverse composition f inverse. The meaning is in order to find f composition g inverse, we will find g inverse, we will find f inverse, and then we will take composition of g inverse and f inverse, and that will give us the value of f composition g inverse. So, that is all for today's class. Thank you.